Okay, let's solve a system of equations with three variables. So we're just going to do one example here, example 1a. Solving a system with three variables. Okay, when we solve a system with three variables, we could use substitution, similar to the same way that we could use substitution when we had just a normal linear system with two variables. But elimination tends to work a little bit better, especially in all cases. So that's what we're going to focus on here. All right, so here are my three equations that we want to solve. We have x minus 2y plus 3z equals 12. 2x minus y minus 2z equals 5. And 2x plus 2y minus z equals 4. Now think again to what it meant when we were solving a system of equations with two variables. It was where our two lines intersected. In this case, it's where all three of our lines are going to intersect. And remember that our three lines are going to be moving through space somehow, so 3 dimensions. Okay, when we start solving our system of equations, first of all, I find it helpful to label my equations, equation 1, equation 2, and equation 3, just because that helps me keep my work a little bit more organized. Now, to get us started, when we are solving a system, we need to figure out what variable could we eliminate. All right, my general strategy over here. What variable could we eliminate nicely? And looking at my equations that I see here, I see I have a negative 2y and I have a positive 2y. So that's going to work out. And I'll add here, what variable could we eliminate nicely? You only need a pair. So we want to eliminate one variable from a pair of equations. All right, so in equation 1 and equation 3, we figured out, hey, these negative 2y and the positive 2y, these will be able to cancel out nicely. So I'm going to write down here that I'm working with equation 1 and equation 3. Again, just to kind of help keep my work organized. X minus 2y plus 3z equals 12. 2x plus 2y minus z equals 4. To get my negative 2y and my positive 2y to cancel out, I have to add my equations straight down. X plus 2x is 3x. Negative 2y and positive 2y cancel. 3z plus negative z is a positive 2z. And then a 12 plus 4 is 16. All right, so equation 1 and 3, that works out nicely. Now I'm going to do a similar process, but with one other pair. So again, in this case, we eliminated our y's. So I want to pick another pair of equations where I will also eliminate a y. In between my equations I have left, well, I need to work with equation 2. And just because this is a negative y, I'm going to choose equation 3. So I have a negative y and then I have a positive. So equation 2 and 3 now. I have 2x minus y minus 2z equals 5. And 2x plus 2y minus z equals 4. Again, just rewriting my two equations here. But right now my y's can't cancel out. My y's cannot be eliminated. But what I could do, I could multiply my top equation by 2. So this becomes 4x minus 2y minus 4z equals 10. And then my bottom equation stays the same. 2x plus 2y minus z equals 4. So I'll do elimination with these two modified equations now. And to get my negative 2y and positive 2y to cancel, again, I'm going to have to add 4x plus 2x is 6x. Negative 2y and positive 2y cancel. Negative 4z plus negative z is minus 5z. And 10 plus 4 is, equals 14. All right, so after all of this process, I have two equations where I have an x and a z, no y's. Well, okay, I have two equations, two variables. I can solve these like a regular system. So I take my two equations, 6x minus 5z equals 14. And solve like a regular system. So again, just kind of recapping our steps so far. We thought about what variable could we eliminate nicely. You only need a pair. After that, repeat the process. So we still eliminated the same variable, but with a different pair of our original equations. We started off with equation 1 and 3, and then we did equations 2 and 3. Now we're solving this like a regular system. We're solving our resulting equations like a regular system. So 3x plus 2z equals 16, 6x minus 5z equals 14. Just looking at these two equations, I think that x's would eliminate a little bit more easily. So I could multiply my top equation by 2. And I would get 6x plus 4z equals 32. And now my x's have the same coefficient. If I have a 6x and another 6x, to get these x's to eliminate, I need to subtract my equation. So minus everything straight down, 6x minus 6x cancels. Negative 5z minus 4z is negative 9z. And then 14 minus 32 is negative 18. Divide by negative 9, z equals 2. Oops, said 2, wrote 9, z equals 2. All right, we got one variable, so this is good. I know z equals 2. I can plug this in now. Plug that in to either of my two equations here that I was working with. So I'm going to use my top equation, I guess. 3x plus 2z, but z is 2, equals 16. That's 3x plus 4 equals 16. Subtract 4, 3x is 12. Divide by 3, we get x equals 4. All right, I got two of my variables. Now I plug these in. Into our original equations. Into any one of our original equations. So looking back at our original, I know an x and a z. Oh, I'll just use equation 1, I guess. I'll work that out here. So we can still see our original equations up here. So 1x, x was 4, minus 2y, y is the one variable we don't know yet, plus 3z, z is 2, equals 12. It's 4 minus 2y plus 6 equals 12. 4 and 6 together is 10. subtract 10 from both sides. Divide by -2, we get y is -1. So after all of this work, we have an x, we have a y, we have a z. We still write our solution as an ordered pair, x, then y, then z. We have an ordered pair with 3 coordinates because we have the 3 dimensions. So that's how we would write our answer. 4, -1, 2. All right, that's our process. It's a long process, a lot of room to make little mistakes, but again, that's our